Section 3.3, problem 2. So this is asking us for the instantaneous rate of change for this function f of x is equal to negative 4x squared minus 6 at x equals 2. So remember the formula for instantaneous rate of change was the limit as h approaches 0 of f of a plus h, in this case a is 2, so f of 2 plus h minus f of 2 divided by h. So f of 2 plus h is the value that we get when we plug 2 plus h in for the x there. So we're going to get minus 4 times 2 plus h quantity squared minus 6. And if we remember again, 2 plus h quantity squared is the same thing as 2 plus h times 2 plus h, which is going to get us 4 plus 4h plus h squared. Then we simplify that, we're going to get minus 16 minus 16h, and then minus 4h squared, and then we still have the minus 6 there. So let's combine our like terms. We're going to have minus 4h squared is the h squared term, 16h, that's the only h term, and then we've got minus 16 minus 6 is minus 22. And then we also need to find f of 2, and f of 2, if you can verify this, if you plug 2 in there, 2 squared is 4, that's going to give us minus 16 minus 6 is minus 22. Okay, so then if we plug this into our formula, we get the limit as h approaches 0 of f of 2 plus h, which we just found was this quantity here, so we're going to get minus 4h squared minus 16h minus 22, and then minus f of 2, so minus f of 2 we just found was negative 22. So all of this over h. And again, we're going to find that minus 22, these two minuses will cancel. We're going to get plus 22, minus 22 plus 22. Those two terms will cancel each other out. So we'll get the limit as h approaches 0 of, and those terms are gone. We're just left with those two. From there, we can factor an h out. And when we do that, we're left with minus 4h minus 16 over h. And at that point, these h's can cancel. And finally, when I plug the 0 into the h that's left over, that whole term will go away, and then I'm left with minus 16. So the instantaneous rate of change of this function at x equals 2 is minus 16.